A palindrome is a word that reads the same forwards and backwards. Race car, level, noon, simple idea. But in coding interviews, palindromes show up in a dozen shapes. Check if a string is 1, fix a string so it becomes 1. Find the longest palindrome hiding inside a bigger string. They look like completely different problems, and most people learn a separate trick for each one. Here is the thing though, they are all the same idea underneath. A palindrome is symmetry. It reads the same from both ends. Once you see that, you do not need 4 tricks. You need to spot the symmetry and pick the right tool for it. So we are going to climb a ladder of 4 palindrome problems. Each one will break the tool that solved the one before it, and that break is exactly what pushes us up to the next idea. By the end, you will look at any palindrome problem and know which tool it wants before you write a single line. Start with the simplest version. Given a string, is it a palindrome? The first idea most people reach for is to reverse the whole string and check if the reverse equals the original. That works, but it builds a second copy of the string just to throw it away a moment later. Let's use the symmetry directly instead. If a string is a palindrome, the first letter has to match the last letter. The second letter has to match the second from last, and so on, working inward. So put one finger on the first letter and one finger on the last. Compare them. If they match, step both fingers one place inward and compare again. The moment 2 of them disagree, you can stop early. It is not a palindrome. And if your fingers meet in the middle without ever disagreeing, it is 1. Take race car, R and R match, and a match, C and C match. The fingers meet at the E in the middle. It is a palindrome. This is the atom of the whole family. Symmetry just means walk in from both ends, 1 pass, and no extra memory. And just to be sure the early stop works, take ab car and a match, but B and C disagree, so we stop, not a palindrome. Here is all of it in code. 2 pointers, walk inward, bail the instant they disagree. Now a small twist that makes things interesting. You are allowed to delete at most 1 character. The question becomes, can this string be a palindrome after you remove 1 letter or 0? Take ab car, as it stands, it is not a palindrome, but delete the C and you get abba, which is, so the answer is yes. The obvious approach is to try deleting each letter 1 at a time and check every result with our finger trick, but that is a separate full check for every letter. Slow. Here is the better way, and the nice part is it reuses exactly what we already built. Run the same 2 fingers from both ends. While the letters match, keep stepping inward, just like before. Nothing interesting happens while things match. The one interesting moment is the first mismatch. When the 2 fingers finally disagree, that spot is the one and only place you are allowed to spend your deletion. Why there? Because everything outside that point already matched perfectly. Deleting one of those letters would just break a pair that was already fine. So the deletion has to happen right here at the mismatch. And you have exactly 2 choices. Delete the left letter or delete the right letter, so you check both. Is the stretch a palindrome if you skip the left character, or if you skip the right one? If either of those works, the answer is yes. The lesson here, you don't always need a brand new algorithm. Sometimes you take a tool you already trust and add 1 decision at the exact spot where it is forced on you. Third problem, and it feels like a big jump. Given a string, find the longest palindrome sitting inside it as 1 solid chunk. For babad, the answer is bab or abba. Both are length 3. Notice the new trouble. In the first 2 problems, we were handed the 2 ends. The whole string was the thing to test. Here we are not handed anything. We are hunting for the ends. The brute force is to take every possible chunk, every start paired with every end, and test each chunk with our finger trick. But the number of chunks grows with the square of the length, and testing each one takes another pass on top. That is 3 stacked layers of work. And if you watch it run, it checks the same letters over and over, for chunk after overlapping chunk, never remembering a thing. That repeated, wasted rechecking is the clue. It is the same clue from last time. It means a better structure is hiding. And notice, the 2-finger trick alone cannot save us here because it needs the ends, and finding the ends is the entire problem. So flip the question around. Stop thinking about the two ends of the palindrome. Think about its middle. Every palindrome has a center, and it is perfectly balanced around that center. The left side is a mirror of the right side. So here is the move. Instead of guessing chunks, plant yourself at a center and grow outward. Look at the letter just left of center and the letter just right of center. If they match, you have got a bigger palindrome, so step outward and check the next pair. Keep going until the two sides disagree or you run off the edge of the string. Take abba, put the center on the B, look one step out, and on the left and on the right, they match. Step out again and you have hit both edges, so you stop. The palindrome is abba. Now just do that same outward sweep from every possible center in the string and keep the longest one you find. We went from testing every chunk to growing from every center. All that repeated rechecking is gone. But there is a hole in this plan, and the best way to find a hole is to break it on purpose. Try the string abba. It is obviously a palindrome. So where is its center? It is not on any letter. It sits in the gap between the two B's. Our method only ever dropped the center on a letter, so when we sweep through abba, there is no single letter to stand on in the middle, and we miss the palindrome completely. That is the bug. And the fix falls right out of seeing it. There are actually two kinds of centers. One kind sits on a letter, and it gives you odd-length palindromes, like abba. The other kind sits in the gap between two letters, and it gives you even-length palindromes, like abba. So we run our outward sweep from both kinds of center. For a string of length n, that is n centers sitting on the letters, plus n-1 centers sitting in the gaps between them. Now we catch the odd palindromes and the even ones. And notice what we just did. We did not memorize some rule about odd and even lengths. We watched the simple version fail on abba, and the failure itself told us exactly what was missing. In code, one helper grows from a center, and we just call it twice, once for a letter center, once for a gap center. Last rung, we change a single word in the question, and it breaks everything we just built. Before, we wanted the longest palindromic substring, a solid chunk. Now we want the longest palindromic subsequence. Subsequence means the letters do not have to be next to each other. You are allowed to skip letters as long as you keep the ones you take in their original order. Take BB-bab. The four B's are scattered through it, but read in order they spell BBBB, a palindrome of length 4. Now try our center trick on this. It falls apart. There is no solid block to grow outward because the palindrome has gaps in it, so we need a genuinely new idea. Let's think about a stretch of the string from some position I on the left to some position J on the right, and ask one question about its two ends. Does the letter at I match the letter at J? If they match, wonderful. Those two letters can be the outer shell of a palindrome. So the best we can do across this stretch is those two letters, plus the best palindrome we can build from everything trapped between them. In other words, the answer for I to J is 2, plus the answer for the smaller stretch from I plus 1 to J minus 1. But if the two ends do not match, then they cannot both sit on the outside, so we give one of them up. We take the better of two smaller stretches, the one without the left letter or the one without the right letter. Look at what just happened. The answer for a big stretch only ever depends on smaller stretches inside it, so we solve all the tiny stretches first. A single letter is a palindrome of length 1, then we use those answers to solve slightly longer stretches, and we build up, step by step, until we reach the whole string. We are filling in a table, smallest pieces first. That is dynamic programming. When growing outward broke, we leaned on smaller, overlapping pieces instead. The answer is in the far corner, 4. Step back and look at the whole climb. 4 problems, 4 different tools, but one idea ran through every one of them: symmetry. And here is the payoff, the part actually worth keeping. The wording of a palindrome problem tells you which tool to reach for before you write anything at all. If it just asks you to test one string for symmetry, use 2 fingers from both ends. If it asks for that, but with a small allowance, like 1 deletion, use the same 2 fingers and add a single decision at the first mismatch. If it asks for the longest solid palindrome inside a string, forget the ends and grow from every center, and remember there are two kinds of center. And if the letters are allowed to be scattered, that one word, subsequence, is your signal to switch to a table and build the answer up from smaller stretches. The trigger words are simple. Are you testing a string or finding the best one? Is it a solid chunk or can it be scattered? Those words pick your tool for you. Let's retrace the ladder quickly because the climb is the real lesson. We started by checking one string with 2 fingers from the ends. Then we allowed a single deletion, and all we added was one decision at the first mismatch. Then we went hunting for the longest palindrome inside a string, so we stopped guessing chunks and grew from centers instead, and we fixed the even length case by watching it break on abba. And finally, we let the letters scatter, which broke the center idea entirely, so we switched to filling a table from the smallest stretches up. Every new problem broke the last tool, and that break is what carried us to the next idea. Underneath all 4 problems is one sentence worth carrying with you. A palindrome is symmetry, so attack it from its symmetry, from both ends or from its center. Every tool we built is just that one idea bent to fit the question in front of us. And there is one more rung above these. Our center method actually does a lot of repeated work between centers that sit near each other. If you reuse what you already learned from earlier centers, the mirror image of where you are standing now, you can find the longest palindromic substring in a single linear pass. That is Manacher's algorithm, the one almost everyone memorizes and almost nobody really understands. We will derive it from scratch, the same way we derived everything here in a part 2. Thanks for watching.